All right. So what we're going to do today is I have this little Mr. Coffee machine, and it has different properties associated with it. And we're going to try to simulate this in Ruby by writing a class called Mr. Coffee. And a Mr. Coffee, we're going to first brainstorm a little bit and see what does a Mr. Coffee have in it. What types of properties would I need to have if I were to simulate this machine inside of a code? Okay? So take a look at it, and let's start to brainstorm what kind of things I could have for this. So for those on the video, you don't get to see my little coffee machine, but we'll write on the board here what types of properties does my Mr. Coffee have. Okay, it's got a water container. It has two of them, does it? Well, we've got water for the reservoir, okay. And we've got the coffee pot itself. All right, what else do we have on it? All right, we have a heater. How would we simulate a heater? I mean, what is that? What properties does a heater have? On or off? Okay, good. Now we're getting where. So we have an on and off switch that turns on the coffee maker and turns off. Now my coffee maker is very simple. Doesn't have a lot of functionality to it. What else do I have? A plug. Okay, so it has power. It does have a clock.
So now we have a timer.
So we have a clock. Right, what else? It's programmable. It has delay and an on-off. So we've got a delay. We've got some other properties like that. What else? Okay, we've got a coffee container. So a coffee. What do we call that? A coffee. All right. Well, we have the fact that it might have a filter or not, and it might have coffee. So how would we tell if it actually has coffee? No, I mean the actual dry coffee. How do you tell if it has coffee in it? No. All right, so we might have a coffee level. All right, we might be able to measure that, right? It's something we can measure. What else? Brewing time. All right, so that's in brewing time here. All right. In our water, how do we measure water? There's a little 1, 2, 3 thing on the side. So we measure that in what? What type of cups, right? We might measure our coffee in cups as well. Coffee level. What else might I have on here?
Well, the little thing that shoots out the water into the.
Well, yeah.
We need to keep track of the state of that.
We don't need to. Right. When we're talking about a class, we're trying to keep track of the state of this little machine. So what state pieces does it have? Well, we have whether it's on or off, the power. We have whether it has coffee in it. We have whether it has water in it.
Whether it's brewing or done brewing. Yeah, there could actually be two different settings for the pot itself.
Yeah.
Or not.
We might have the actual brewed coffee.
Yeah, finished product.
Finished. Brewed coffee. I don't even. What else? Anything else?
What about the type of coffee that you put in?
Type of coffee, all right.
Always specify that.
All right, so we've got a couple of brainstorming things here. Let's try to put some of these things into a class now. All right, so remember that a class has state and actions that we can operate on this thing. So we have the class methods, and we have the instance variables that store the state of this object that I create, right? So let's start to create our class. Yeah, go ahead.
Can we use that little
What little cheat? Oh, yes, you can. After accessor, we can use that. From now on, after Wednesday, you can use that shortcut. It's not a cheat, it's a shortcut. Okay. So we're going to have our class. So we start with saying class Mr. Coffee. And the Mr. Coffee here is in camel case, starting with uppercase letter. That's what differentiates Ruby. Knows now that this is a class because it starts with a capital letter. And what follows, I could make it all lowercase after that. But by convention, and Rails does this a lot, you'll see they make it camel case. And they actually use that to change classes and things. It generates code based on the fact that it is camel case.
Camel case, first letters, capitalized though.
Yeah. I just said it was. That's right. You're saying that it would have to be this. Well, that's a semantic issue. Camel case starting with a capital letter is what I'm saying. It's not. What do you call this? I just found this.
Make up your own rules as you go. It's okay.
That's exactly what I do. This is the These are what they call the Ruby conventions. This is what do they call this kind of a statement?
I call that
It's not a camel case. It's It's called a snake case. I never knew that. That was a new thing that I just found out. Anyway, useless trivial information. So there's our class. We've defined it. That's a start. What's the first thing we do with a class? We initialize it, all right? So we're going to write our method called initialize, and we're going to pass some information maybe to our initialized class. So let's talk about our brainstorming here. What do we keep track of? So we have our power. All right, we have a power variable. What else might we have? Our water level. We'll call it water level. What else? All right, our clock. Coffee level. Okay, our brewed coffee level. A filter, okay. And we'll talk about what these actually are here in a second. We have a filter we need to keep track of. The heating, all right, we might keep track of the heating temperature, the element temp. We might call it that. We could call it that. I just did. So what type of value is power going to be? Okay, it's going to either be on or off. There's no fuzzy logic in here. We can't be partially on or off, so it's going to be a Boolean. How about our water level? It's going to be an integer, some number, which represents what? Integer. Okay, cups of water. And would that be, could we have a partial cup? So instead of an integer, maybe it might be better to be a float. Okay, good.
I just looked it up, David. Pascal case.
It's called what?
Pascal.
Pascal case? Interesting. Never heard that term. All right, clock. This one is, you mean? Yeah. Interesting. All right, clock can be keeping track of what? Time. Okay, so we're going to have a time object here. Coffee level is going to be what? Okay, probably a float again. We're going to keep track of, cups. That's the dry coffee. All right. What's something that's more generic in there? You want tablespoons?
Enough measurement.
Well, it wouldn't be cups for sure.
How about ounces?
Okay.
So instead of my value up here, I might have ounces as well.
Those would be also make
What?
a variable called brewing time.
Brewing time.
And track how much coffee you put into what, how much you have now.
All right, so we'll have another one. So brewed coffee level, this is how much coffee gets spit out into the little coffee pot. So this is my wet coffee, my product, ounces. And we're going to make a float again. We're going to have ounces. All right, this is my finished coffee. And a filter. Okay, we decided it either has a filter or it doesn't. So this is going to be a Boolean. Brewing time. So it's going to be a time type of an object. And the element temperature,
Probably.
a Boolean.
I think it would be a
Float as degrees. All right, degrees what?
Celsius.
Celsius? Okay. You don't want to go with
No.
Fahrenheit. All right.
Kelvin.
We want our program to be
Used around the world. Good. You're thinking globally already. That's good. All right. So when we initialize our coffee maker, it comes off the line. I like to think of this as coming out of the manufacturing plant. All right. It created this little Mr. Coffee machine, and they put it into a box. And what are the properties of the coffee machine as it comes out of the box? Okay, so our power is going to be off. So this is going to be, we're going to store that as a 0 or a false would be better. How about our water level? 0.0, it's going to be a 0.0 float. Our clock, all right, so in Ruby, we have this class called the time class, and I can say time.now, and it tells me the time that it is right now, exactly right now when I called that. And if I call it again, notice how the seconds are different. So it took me 8 seconds to say that it was the same time here, okay? So 8 seconds passed between the time I hit time now and time now again. All right? So other features of that, I can convert that to an integer. All right? An integer is representing the number of seconds since what time? Since the beginning of time, which is what in computer terms? When is the beginning of time in computers? Right, epoch time. January 1st, January 1st, 1970 at the midnight before. You know, it's New Year's Eve minute, New Year's Day minute, right after 1969 midnight, December 31st, right? So that's the number of seconds that have occurred since that point in time. So if I call it again and I convert it to an integer, what do I get? The number of seconds again from the time that I did that. So I have two values here. And if I want to figure out what has happened, how long something has occurred, I can store time.now.2i as a variable. And what is a now? It's no longer a time object. It's a integer. It's a number. And I can say b is time.now.2i. And they have two different values. Now how do I get the number of seconds that have elapsed between a and b? B minus a. I take the farthest one in the future and I subtract the farthest one in the past. So the most recent one minus the oldest one. Otherwise, I'm going to get a negative number. If I say a minus b, I get a negative 14. Have negative 14 seconds passed?
Do what Joey said.
What? Add them together and divide by 3 and multiply by
Exactly this second next year.
A divided by B? No. A plus B. Yeah, that's not next year. That's
From 1970
40,
to now.
43 years from now. Yes, you can convert a number of seconds into a date. Yes. All right, so 14 seconds passed from the time that I created my A variable to the time I created my B variable. So that's a quick rundown on the time object. So when I create my clock, I'm going to set it to time.now and make it a time object.
You gotta think the power's not on, so
True, but I can set that to whatever I want.
set it.
I can make it 0 if I want, but
Reset it when the power goes.
true, right? Absolutely. So you want it 0? Fine, you can have it as 0. All right, our coffee level is in ounces, and it has no coffee coming off the manufacturing line. It has no brewed coffee because it's not brewing anything, so that's also a float. And does it have a filter or not? That's going to be what? Does it come shipped with a filter? False. No, not in its time. So the brewing time is a time object again, so since you want it 0, we're going to make it 0. Our element time is what?
10. That's gonna be 0.0.
All right, so it's the number of degrees.
Another Boolean in there that says if it's brewing or not. And either is that hour. We can assume that's hour.
Actually, he is right.
All right, so brewing would be a true or false, right? A Boolean. So we'll say brewing. What is happening? I don't know what to call that. Just put Boolean. All right. So we've got our class. We initialized all of our nice little variables when it came off the line, and now we can actually create our Mr. Coffee class. Now, outside of this, we're now writing our main program. This is our main program to deal with our Mr. Coffee. So the first thing I need to do is create my coffee machine. So I hate to use this, but I'll call it my coffee. I just don't like this term. They do this a lot in C++ and things like that. But my coffee, my Mr. Coffee, how do I create a new item off the line? Okay, it's actually the other way around. Coffee.new. And I'm going to, which is different than C#, I know. You gotta learn 4,000 different ways to do the same thing. So I might pass some things into this, I might not. All right? It's already got everything it needs. So let's leave it like this. We're not going to pass in anything. We're going to create it as if it came off the line. And now my Mr. Coffee is it's ready to go, right? I can now use this, and let's call the inspect method on it and run it and see what I get. So I get my Mr. Coffee, comes from the Mr. Coffee class, its location or ID in memory, and all of my instance variables are all set for me. All right? Isn't that great? All right. So, any questions on where we're at right here? Okay, you should be writing those in your sleep now, initialize methods. We figured out what these all should look like. I wonder if the... no.
Now, is there any way to set a maximum for water levels?
We're going to have to, right? We're going to have a maximum level. All right? So a maximum level, this might be useful as a variable, or really, it's really kind of a constant. It's not going to change. I'm not going to allow somebody to add a maximum level to my coffee. They can't add another reservoir tank to my system. So it's never going to change. It's always going to be the same value. So I could store that, I could make a constant out of it. But for purposes of learning here, I'm going to make it an instance variable instead. And we make it, class variable instead. And we'll call it max water level. And it's going to be set to some number of what? Some number of what? Ounces, okay? So this one holds about milliliters. All right, so it's going to have a maximum of 10.0 ounces, okay? It's a small little guy. It doesn't create very much.
That's a 32 ounce.
No way does that hold 32
Yeah,
ounces.
it's 32 ounces.
It's 4 cups, which is 32 ounces. Fine.
We can use that same
10
variable
ounces
for
is
the max
making a cup
coffee,
of coffee.
that the glass part can hold.
No, because there's going to be some boil off.
You want to get too technical. Right, so I've got a nice little class variable, and since this isn't going to change, it's going to be available across all the Mr. Coffees in the world that come out of this class, all of them that come off of this assembly line. All right, so let's start to create some methods to interact with our little Mr. Coffee machine. So the first thing we might want to do is to turn on or off the coffee machine, right? We do that with our power button. So I need a method to change this value. All right? So I can call it whatever I want. And what do we want to call it? All right? We could make this, expose this variable to the outside world by giving it an attrexessor, and that will create a power method and a getter and a setter for me, right? So if I did it the old way, I would say power, and this is going to set the power to something, and I don't even have to add any. Let's see, power. This is going to be a getter. Sorry, this is a getter, and I'm going to return what? Whether it's on or off. So I return the current state of my coffee machine. So I'm just going to return my power variable. And a setter for this would be what? And we're going to set our variable power to be equal to whatever they pass into this. All right, so that's one way to write that. That's a getter and a setter for my power. Yeah, absolutely. So there are some other ways to write this when we're trying to simulate things. We want to protect the user from themselves. We want to protect the user from screwing up my coffee machine by adding too much power or something, or adding a string to my power, and that will screw up my whole power system, right? So instead of writing getters and setters like this, I could write a method called something like, I'm going to delete these. I'm going to call it turn on. And how would I turn on my coffee machine? So in that case, they don't even know that I have a variable called @power. I don't make it accessible to the outside world. They can never change this unless they call turn on. And what would be the opposite of turning on? All right, so I'd have another method called turn off. And I set my power to be what? All right. Isn't that great? So instead of letting the user just pass anything into this, I'm not letting them pass anything at all, and I'm controlling my variable now. I've now hidden that value completely from the outside world. That's the true value of what they call encapsulation, which is what you're supposed to be researching, I think, in one of your researches. So we've encapsulated this value. We've kept it safe from the user themselves. Right? Everybody understand that? There's no way now to tell, is the power on or off? How do I tell? All right, I might return some value if they ask for, is my machine on or off? If my outside world says, is my machine on or off, I want to return something, right? So in that case, I might want to write a getter for this variable. Because it's a Boolean, I might as well just return the value of whether power is true or not. So how would I write just a getter using my shortcuts now? All right, I just want to read the value, and I give it the symbol of the instance variable that I have here. And it will create that method for me, which is the same thing as writing this method. All right, what it does is, and I'll put the return in here, that line writes this code. All right? Everybody see that? That's really all it does. You don't have to think any more about that. So now I can try to play with that, and notice how I'm creating my coffee machine. I'm creating my variables. I then go down to my main program and I play with it a little bit to make sure that those methods that I just wrote actually work. I don't want to write every method under the sun and then go back and try to run it, because I have no idea where the errors are. I want to test each method now that I've written before I move on to the next code. So I want to test my turn on, my turn off, and my getter for my power. So my Mr. Coffee is here. I'm going to say my coffee, and I want to turn it on. Right? That turns on my coffee machine. And I can then print out the value of the power of the coffee machine to see if it's true or not. And then I can call Mr. Coffee and turn it off and print off the power again to see if it actually turned off. All right, so these lines of code here, turning it on, looking at the power, turning it off, looking at the power, have exercised or run these two methods and my attribute reader. All right, so let's see if it works. So I turn it on, I get true, my power is true. I turn it off, my power is false. Look at that. Is that cool? Isn't that sweet? Yes. This way? All right, any questions on that so far? All right, we've got a long ways to go, but we'll continue on with this Mr. Coffee class tomorrow, and we'll start adding water, and we'll write methods to turn on the brewing and some other stuff like that. Maybe keep track of time. I'm not sure. That's kind of writing your program for you, so we'll see. Yeah, I think you need to see that. All right.